Good evening. Okay, write this number, huh? 4567. Good evening all. Is it visible to everyone? Jumping, jumping. Sumit, yes, but we will see. We will see that what will happen. Actually allowed, but we will see. This is visible. Start to do the numericals. Easy questions only supporting the concept. To support the concept here. So try to answer quickly. Finish all questions. Yes, Sumit, actually we received, but we will see today what date 10. Sierra 66, 7, 8. Easy, direct questions. When you people finish these three, just send me, then I give you more, step by step. 66 option C is correct. 67 also C, correct. 68. Become K6, correct. 67. 69, 9. C equal to epsilon naught A by D, 2 given. Then C dash equal to K epsilon naught A by 2 into D. So K by 2 equal to 6. 2 cancel. K value 6. 69. So capacitance of the parallel plate capacitor or in the presence of dielectric of thickness T. Formula I gave you epsilon naught A upon D minus T into 1 minus 1 upon K. Use that formula. Here T given D by 2. Find the C dash first and then take percentage of increasing capacitance. C final minus initial by initial into 100. D value D by 2 half filled. So find the value of Cm. C value is epsilon naught A by D. K value given 5. 5 by 3. Final is 5 by 3. Final value is 5 by 3. Final value is 5 by 3. So what is the answer now? They ask you to determine the percentage. What is the percentage? Very good, Pritam. Akash, correct. Finally, C 5 by 3. So percentage is 5 by 3 minus 1 upon C into 100, 2 by 3, 66.6, 70, 71. Arpita answers the given questions. Yara Priyanka from Jasper. Sleeping or doing? In class you are getting sleep. But here very good, very good. Do. 70 answer. Two capacitors C, another one dielectric KC. So answer is C1, C2 upon C1 plus C2. So answer will be A. C1, C2 upon C1 plus C2. KC by K plus 1. C1, C2 upon C1 plus C2. KC by K plus 1. C effective equal to C1 C2 by C1 plus C2. C1 C, C2 value KC. Series. Now 71. Straight question. Filled with the two dielectrics. Constants 4 and 6. Now two dielectrics not specified whether they have filled half of the area or half of the distance. So we assume here should be half area only. This one K1 now. This is K2. You can take this is C1, C2. Now what is here? We both are parallel. C1 plus C2. C1 equal to how much? K1 into A by 2. Epsilon naught A by 2 by D. C2 equal to K2 into epsilon naught A by 2 by D. Because here area of. Now apply condition. Tell me. And epsilon naught A by D value given 1 microfarad means this is the K1 K2. CAB equal to K1 plus K2 by 2 into epsilon naught A by D. Suppose if they are connected in series like this, they, for example, the same thing like this. K1 no, this is K2. For this case formula we have, that is CAB equal to 2K1 K2 by K1 plus K2 into epsilon naught A by D. Keep remember both. If they are series, this condition. If they are parallel, one condition. 4 plus 6 by 2. 5 answer. Now, 72. Energy stored. Heat produced means is nothing but energy stored in the capacitor should converted into heat of CV square. Very good. 73. There are n capacitors in parallel connected to V volts. Then energy stored equal to half n into CV square. Energy stored is n into half CV square. Correct. Option should be. What do you write here? Option B. Of n into CV square. Half into n into CV square. B. Half into n into CV square. Now, yes, you require the formula. Now, a capacitor charging connecting to the battery across its plates, it stores the energy. Now battery disconnected and another identical capacitor connected across it. Now energy stored by both capacitors of the system will be. Good question this. Try. So, but I give you hint to you. May or may not you remember common potential formula. C1, C2, V1, V2. If the positive terminals are connected, positive terminals as well as negative terminals are connected, what is the V common potential? V common. V common is equal to how much? C1 V1 plus C2 V2 by C1 plus C2. If second capacitor is uncharged, V2 you should write 0 only. Okay. See, you know, two charging capacitors are connected. The charge will flow from higher potential to lower potential till both gets the common potential. Here delta U is equal to loss of energy of C1 C2 by C1 plus C2 into V1 minus V2 whole square. So related to that, but they ask you the energy of the system. First one, connected to the battery with a potential V1, C1 also VSC, U equal to half C into V1 square. Second case, what they do, removed from the cell and connected to the uncharged capacitor V2 0. This is V1. Then V equal to what I write? C V1 plus C2 into 0 by C plus C2. Means C1, C1. C V1 upon 2C equal to V1 by 2. Now total energy will be equal to how much? Unit equal to, here both are parallel. Both are parallel means I use half into C plus C into V1 by 2 whole square. What I get? Half into 2C into V1 square by 4. Cancel. So half C V1 square will get U by 2. Will get U by 2. Concept important for entrance. Common potential formula. But total charge in the system remains constant. Total charge in a system remains constant. Got this procedure? This is for the loss of energy, but not energy of the system. It's only energy of system. Loss means final minus initial. This is only final energy of C V square plus of C V square. Both are same. C plus C. Both are parallel now. Unit equal to half C into V square plus half C into V square. Now 75. Imra got this procedure all common potential. And now you see, suppose You know, I reminded you. This is the time to reminder you. See here. Now suppose this is the radius R1 and radius is R2. Both are connected. Now what happened, Newton? If both are connected, charge flow from the one to another till they get a common potential. Suppose net charge let it be a Q initially. So final charge will be Q dash should be equal to Q. Q dash means this is C1. C1V plus C2V equal to Q. V equal to Q by C1 plus C2. Common potential formula. This is net initial charge in a system. When you connect it with a wire, automatically charge will flow. And the final Q final will be equal to Q initial. This is the point here. Listen. C1 equal to isolated sphere R1, C2 equal to 4 pi epsilon naught R2. So V common is equal to formula Q upon 4 pi epsilon naught into R1 plus R2. Sir, I want to calculate charge in the first one. Q1 dash is equal to C1 into V. So, V nothing but this one, V common. C1 dash 4 pi epsilon naught. 4 pi epsilon naught R1 into V. Cancel. So, R1 into Q by R1 plus R2. Q dash equal to C2V. 4 pi epsilon naught R2V. R2 Q by R1 plus R2. This is required cases for all elements of the exam. Charge of the each bipolar isolated spheres after distribution will be R1 by R1 plus R2, R2 by R1 plus R2. Now you see, in Coulomb's law, we did one model, isn't that? Charge is Q1. This is Q2. Of course, for example, this is 10 coulomb. This is 5 microcoulomb. 5 Q2. If they will touch and will separate, what is the charge on each? What is the charge on each? 10 no 6. Both are in contact and will separate. What is the charge on each? You know that Q1 plus Q2 by 2 because they are identical or non-identical. These are identical. If they are not identical, formula you see. R1 equal to R2, Q by 2. We are correct absolutely. But if they are not identical, this is the basic formula. Try to memorize. Try to memorize all. They are isolated and identical spheres, but here are dimensions of different. Now tell me the answer for 75 and 6. Proceed. 75 D about proceed for next question. 76. Capacitor of capacitor C charge Q. Charge is Q square by 2C. Q is double. 4 of Q means 4 W. Correct. 76. Charge 10 minus 2 are given to the plates of capacitors which are connected across the battery of 12 volts. Find the capacitance of capacitor. C equal to what we write? Q1 minus Q2 by Q1 minus Q2 by 2 into C. N minus 2. Ask me to find V. 8 by 12. 4 by 3. 76. Q1 minus Q2 upon correct. Q1 minus Q2 upon 2 into the formula. So 10 minus sub minus 12 upon 12, 1 by 2, 0.5. We did, whether you remember or not this process, you can once again. So here is a C, B equal to Q1 minus Q2 by 2C. C equal to Q1 minus Q2 by 2B. Point 33 or 0.5 be a negative. Point 33 or 0.5. By giving the negative sign here, we get that answer. So you put only magnitudes. Okay. Last, only 4 questions. Only 4. Very good. You are done. Easy. These are easy. Conceptual. A charged with amount of Q dipped in the oil tank, oil pumped out. Field between the plates will be. Conceptual. Take screenshot and all. Take a screenshot. 77, 78, 79. Easy. Anybody answer? Now good. Answer was 77. Only 3 questions. Take a screenshot. You be clever, then answer straight. Little. Okay, thank you all. Bye-bye. What is the answer, Akash Dev? Because reason. What is the reason? If it is continue to connect to the battery, electric field same. If it is disconnected from the battery, electric field decreases. The point is that. Okay. Thank you all.